All right, today I'm going to show you how to do the lab, and you'll have today and tomorrow to finish this lab. What you need for the lab is you're going to need a laser. I've got a small one here because it fits on my desk. You're going to need one of these D-shaped dishes. You'll need to fill this nearly to the top with water, and you'll also need something to measure angles, and I prefer to use a piece of polar graph paper. Um, this polar graph paper is inside of one of these plastic pages because sometimes a little bit of water gets dropped around during this lab. The key to this lab is the D-shaped dish, and what we're going to do with it is we're going to bring laser light into the front side of the dish. And if it comes in at an angle, it will then refract in the water. And the D shape is important because then after it refracts at the front side, when it goes to leave the dish, it's leaving along the normal on the way out. No matter which way it goes, it's leaving along the normal. So we get refraction at the front end between air and water, and then no refraction at the back end. I like to use the polar graph paper as if it was a protractor by taking the dish, and here's the one I have that's full of water. And I like to set the dish on the polar graph paper using the line of 0/360 lined up right with the center of the dish, and that is going to be my normal for incoming laser light. Then my normal for outgoing laser light is going to be measured away from the 180 line. So angle coming in measured away from the 0 degree line, and angle going out measured away from the 180-degree line. And then what I do is I turn the whole paper um, the whole time. It's kind of a useful thing. By the way, you're going to need one member of your group just trying to make sure that this dish is positioned correctly so the center of the dish is, now I haven't got that right, have I? There we go. The center of the dish is right over the, there we go, right over the center of the graph paper, then it works well. Okay, so let's turn on the laser here and let's get this set up so it looks kind of square. All right, my little laser gets turned on. And we want to make sure that the laser light is A, going through water somehow, and it doesn't look like it is. Okay, so I turn the laser over. I think that might help out a little bit. All right, now locating the laser spot is really difficult. So I like to use a pencil. If I put the pencil right here on the line that says 0 degrees, you can see that the laser is hitting the pencil, and it hits the pencil all the way over here. Let's see if I can do this by tilting it this way, right where the center of the dish is, and then you can find the spot where it's leaving back here. It looks like I'm off by about a degree on this deal. So let's just move this over a little bit. Okay, there we go. So we have 0 degrees away from the normal on the way in, and we have 0 degrees or 1 degree away from the normal on the way out. Then we can turn this 5 degrees, and we have 5 degrees angle on the way in, and we have 4 degrees angle on the way out. Then we can turn it to 10 degrees or so. I'll get this just right. Make sure that the laser's hitting the center. Okay, it's a lot of jockeying and adjusting, but we have 10 degrees on the way in, and now we have, looks like about 8 degrees, maybe 7 or 8 degrees on the way out. So using the pencil to find the laser spot allows you to A, find the laser, and B, the pointer of the pencil points at the angle. So it makes it very easy to take the measurements. Now, I say easy, but when we start getting to angles that are very steep, and this is going to take some adjustment on my part, where are we hitting? Okay, so we're not quite hitting the right spot. There we go. And we're coming in now over an angle that's very nearly 60 degrees, about 58 degrees. If I was trying to measure for 60 degrees, I might be happy with this because everything seems to be working pretty well. And then it's coming out. Now I got to move away from the 180-degree mark. How many degrees is that? 10, 20, 30, 46. So 60 degrees on the way in, 46 on the way out. You got a serious amount of refraction going on here. And when you get to angles like 80 degrees, this is going to be dang near impossible. So just have some patience, stick with it. Okay, that's 80 needs to be right about there. No, 80 needs to be right about, okay, there we go. And then on the way out, wow, 50 or 60 degrees. Man, that must be 60 or so. Anyway, so every 5 degrees on the way on the incoming angle, and then figure out what it is for the outgoing angle. Take all the data, and then you're going to graph sine of theta 1 versus sine of theta 2. That's the lab today.